Hi everyone. I'm gonna make a series of videos answering your questions that you handed in from the homework about volume. So this first question is either from Eliana or Anais. Neither one of them wrote their name, so I don't know whose this is. But the question says, "How does the shell method determine volume?" Well, what it's really doing is, so let's say that you had a picture that looked like this, and now it's going to be revolving over the x-axis like this, and it's going to turn into a solid. If that's really no different than if it, let me erase this, if instead it revolves this way, and you can still have a solid, I hope I'm answering your question, and this is the solid figure. So why does it work? It's because when you use the shell method, and remember you have the x, and then you have, whatever over here. This x over here represents the distance, and I think Osman mentioned that it has to do with the height. It's the distance, because normally if we were going to go over the y-axis, we're going right to left this way. And it's taking into account that since we're now doing a top minus bottom, this is the top and the bottom here, it's this x over here is taking into account like the difference in what the height would be, sort of. I mean, I think that's the best way that I could explain it. So, I mean, I don't know. We have different formulas for areas of things. We have the area of a triangle is 1/2 base times height, but in geometry and trigonometry, there's other formulas for the area of a triangle that uses trigonometry. So it's, it's still going to get you the correct volume. It's just a different way of doing it. Okay, the next question, also from either Eliana or Anais, was how does a graduated cylinder, if it doesn't cover the region completely, why does it declare all of the volume with the shell method? And this is, I think, what you're trying to say, maybe, is if it was something like this and it's rotating here, then you have all this empty space over here. So why doesn't it, like how is it taking into account the empty space? I think that's what you mean. That's where that formula where the x is involved takes that into account, because it would be like the length from here to here, or from here to here, or from here to here, and that's all taking that into account. So I hope I answered your questions. Okay, the next question was from Bernadetta. And some of you, many of you, have a lot of the same questions, but hopefully as I go over it over and over, you'll start to get it. Okay, so Bernadetta's question about volume is when to use the shell method, and does it really matter what method you use? So no, it doesn't matter what method you use, because as long as it works, it's what we care about. Okay, so what method do we use? So if we have, let's say this is our picture here. If we're going to revolve it over the x-axis, then it started up here on the top and it ended up here on the bottom. And that's why when we use the integral, we're going to do the top squared minus the bottom squared, dx. And why is it dx? Because it's going over the x-axis. Okay, let's change it up a little bit, and let's say that instead, we're not going to go over the x-axis, we're going to go over the y-axis. So if it goes over the y-axis, it's going this way. So here's the y. Okay, so now it was on the right side, the original piece over here, and it's moving to the left side. So that's why we would do the right minus the left, because it was on the right and it's moving to the left. Now I think that, who was it? I don't remember who asked this question, but they had asked, it might have been Zach. Let's go back to if this is the original picture, I'm sorry, that wasn't what his question was. It was, what if you started down here? What if this was the original? If that's the original and now I'm coming up here, so now I will, make the dotted line, I'll go this way. So now I'm coming up there. How does that change it? Okay, so I was on the bottom, and now I'm moving up here to the top. So that's when it would be bottom squared minus top squared. So you just have to say where were you originally and where did you end up? Did you start on the right and go to the left? Did you go to the left and move to the right, the bottom to the top to bottom, etc. And you just follow that order. So Bernadetta, I don't think I fully answered your question because you said, how do you know when to use the shell method? Oh, let me just get rid of this mess. I'll just go to a new sheet. So I would use the shell method if, I'm just making a generic picture here. I'm here and I'm told I must go over the y-axis, which means I have to end up over here. Well, that would be going from the right to the left. So when I do right minus left, that's a dy. That's no longer a dx. So when I do that, that means whatever function I put in here for the right and for the left, it must have y's in it because you can't mix x's and y's. So if I had something like y equals, let's say x plus 2. Let's say y squared equals x plus 2. Let's say that was the function. Okay, I needed to be x equals, so I have all my y's. Well, I could do that. I could say that x equals y squared minus 2, and it's not an issue at all to do that. But what if instead I had something like y equals x cubed plus x? There is no way that you can get this in the form x equals because the exponents are different. One has an exponent of 3, one has an exponent of 1. You'll never get it in the form x equals. So what are you supposed to do? There's got to be a way to find the formula, but you can't get it, so there's only y's here and here. That's when you use the shell method. When you get stuck and you cannot get it in the form x equals. Now, I know some people had asked, can I use the shell method even if I can get it in the form x equals? Yes, you can use the shell method as long as you're going over the y-axis. Then you're good to go. And Bernadetta had a follow-up question. When do you set the functions equal each other to get the interval? Okay, so let's say that you have two functions. I don't know, I'm just going to say y equals x squared and y equals, x plus 2, for example. And you need to find the area between these two curves. But if I give you an interval, I don't know, I'm making this up, and I say from 1 to 4, then you know you have to set up your limits like that from 1 to 4. But if I don't give you from 1 to 4, then you have to know where these two things intersect. So that's when you set them equal to each other. And then it's a quadratic, so you're going to set it equal to 0. Bring everything over to one side. Oh, actually, this is it factorable? No, this is not factorable. Maybe if I change this, I can make it factorable. So, how about like that? Would that be an x minus 2? No, that's not factorable either. Okay, well, let's just pretend it's factorable. It doesn't matter. You'd end up getting two answers, x equals this and x equals this. Those would be the two limits that go into here, here and here. Smaller one goes on the bottom, bigger one goes on the top. So we set them equal to each other only if we want to know what those limits are of the integral. That's when we do that. Okay, our next question is from Julia. Okay, and she wants to know, when is it necessary to use the shell method to find the volume, and when is it possible not to use it? So I think I already answered the question of why it would be necessary, but when can you not use it? Well, if I'm up here and I need to rotate over the x-axis over here, you cannot use the shell method. The shell method is for when you're going this way. Or, you could also use it for going that way, but it's got to be over the y-axis. So that's when you could not use, that's a good question, Julia. When can you not use the shell method? If it's going over the x-axis. Okay, I'll do two more. So the next one's from Michelle, and her question is, how do I know which formula to use? What is the difference between each? Okay, so first of all, don't forget we had area, and so when we're doing area, because this is part of this topic, area is just the space between two functions. So it's just going to be the top function minus the bottom function, and that's dx. Or it could be the right function minus the left function, and then it's dy. I don't know why I'm writing lefty. Okay, and then it would be dy. Okay, there's no pi, there's nothing's being squared, this is just area. When we use the formula with the pi, and then we have two functions being subtracted, and they're squared, that's for volume. Okay, so these are for area, and now these would be for volume. So if volume, you have to know how it's rotating. So if it's rotating over the x-axis, then it has to be a dx. Everything's in terms of dx, and it would just be the top squared minus the bottom squared. If you were going to do the volume around the y-axis, then you would do the right squared minus the left squared, and then of course it's in the form dy. So the question really is, what's the difference between each? Well, for area, you're not squaring anything, you don't have a pi. That would make sense, because think about, if you're going to be multiplying something by pi, it's going to get bigger. And the volume of something should be bigger than just the area, like of a flat surface. And so basically that's the difference between each. Okay, and I'm going to do one more for this video. And this is from Vicky. And she said, when exactly do we use the different volume formulas? I think I answered that. And when would we use the shell method over the washer method? Okay, so the washer method, the disk method, all the, if it's if one of the functions is the axis itself, you're always going to use that top squared minus bottom squared. So again, you're only going to use the shell method if you must rotate over the y-axis. So you have some function here, and then you have to move it over to here. But you can't, when you do that, when you go right minus left, remember, you're going to end up with a dy, which means you can only have y's written over here. So you can't have a function like y equals x squared plus 2, because you can't put x squared plus 2 here, because there's a dy. So you're going to have to change it to x equals. If you cannot get it in the form x equals, then you have to use the shell method. Really, that has nothing to do with compared to the washer method. You just use the shell method when you're going over the y-axis. Sorry, I mean to erase that. You're going over the y-axis, but you cannot get it into the form x equals. So I hope that answered some of your questions, and I'll keep making videos until we've answered all of them. Okay, hope this helped.